Hello, I'm Julie Cole. Today I'll be looking at the week of weather from Tuesday, January 26, 2016 to Sunday, January 31st, 2016 and discussing patterns, forecasts, and accuracy. Tuesday, January 26th shows two lows directly affecting the state. One located here in the Bering Sea at 964 millibars with significant winds associated with it. The isobars indicate that it is a relatively strong system. A weaker low is in the Copper River Basin region at 984 millibars with weaker winds north of the occluded front, but stronger winds below. Those winds look to be primarily the result of a very strong low in the Gulf of Alaska, down here at 946 millibars. We can see the close proximity of the isobars and the associated comma cloud pattern pushing northward. Wednesday's weather map shows that low that has weakened to 955 millibars has indeed moved up into the interior of Alaska in this occluded front here. A second low at 956 millibars is developing along with it, and the low in the Bering Sea continues to weaken but maintains the cloudiness out here associated with that low and winds that we can see in the isobars. On Thursday's map, we see how the low has weakened to 976 millibars and has dissipated, the isobars becoming further apart. There is still rain and snow associated with this low pressure system, and the second low from the Bering Sea that has now moved into Bristol Bay. Clouds are not as concentrated, and there is some clearing we can see with the darker areas out around those lows. Friday has cleared significantly with the increasing pressure, and while the lows continue to persist, we see several of them, they are not as strong. A new occluded front is located in the Aleutians, which is the strongest low in the state now at 973 millibars. But we can see how the isobars are really far apart now in the interior, throughout the interior of Alaska. And so not as strong winds, not as much changes going on as quickly there. As we would predict, the interior of Alaska has continued to clear on Saturday, and the low has been replaced by this high pressure system. The Aleutian low is strengthening now at 969 millibars and bringing quite a lot of rain and snow showers with it, and persisting with that, with those clouds and the comma formation associated with that low. Sunday shows the path of that Aleutian low persisting with intensity. A lot of closely spaced isobars still at 968 millibars as it moves northward up through the Bering Sea. The west central region of Alaska only now is affected by its clouds and weather. The interior high persists, but moves slightly eastward into the Canadian area over here. Looking at the National Weather Service temperature observations, we can correlate the temperatures with the locations and patterns of the lows and highs. At the beginning of the week, the lows were situated to the south of Alaska and then moved up through the interior, slowly dissipating and then being replaced by that high. And we see this reflected in the temperature plots. Sandpoint and Nome have definite maritime effects since they are right on the water's edge, and their temperatures have much less fluctuation than Fairbanks and even Bethel. And so here we see at Sandpoint that low in the beginning part of the week keeps the temperatures pretty moderated, but as that high becomes established, the temperatures drop until the low comes back in and raises the temperatures again and brings with it the clouds and the warmer temperatures. And here with Nome, we can see the same situation where at the beginning of the week with the low, the temperatures are pretty stable and higher. And then as those lows move out, being replaced by the high, the temperatures dip. And then as the low comes back in across the western central area, the temperatures increase again with the clouds and the low pressure. Bethel, though somewhat inland, also experiences cooler temperatures until the low brings in more cloud coverage towards the end of the week. And here we see that where the temperatures are increasing significantly. At the beginning of the week, however, with the low that moves through the interior, they receive some of the warmer temperatures, but not enough cloud coverage to keep the nights warmer. So we see how they fluctuate more than at Sandpoint and Nome. Fairbanks, being in the interior, sees the most fluctuation. As clouds increased the first couple of days, the temperatures rose with the low pressure system. And Thursday, as the high began to settle in at the end of the week, the temperatures dropped with the clear skies, and that we see that serious drop off on Saturday night, where that high was centered right over the central interior, and Fairbanks would get the result of that with the cold nights and the cooler days as well, without having the clouds to maintain the insulation. So in these maps, we see that the persistence and climatology both show skill to some degree, but also show failure. Sandpoint had the best persistence results for the forecasts, and Nome only had one failing persistence forecast for Sunday. Bethel had two accurate, both for Friday, one moderate skill level for Sunday, and on the 5-day forecast failed for Sunday and in the 3-day forecast. Fairbanks had the worst results, failing Friday and Sunday forecasts from Tuesday. Friday's next day forecast was accurate, but Sunday's from Thursday was only a B. Using the National Weather Service data and computer models had similar results, with Sandpoint being the most accurate and Fairbanks having the greatest errors. Again, there was evidence of skill to some degree for each of the locations, with results gaining a greater margin of error, the greater the extension of the forecast. Sandpoint was the most accurate, probably due to the fact that its maritime climate maintains more stability. And the same is true for Nome, with that stability with the maritime climate. Bethel seems to be just far enough inland to begin seeing more of the fluctuation of systems and the heating and cooling. And Fairbanks is the most extreme, being right in the interior, to experience the cold persistence of the high pressure systems and the daily fluctuation. Temperatures in Fairbanks do not become more stabilized unless there is a low pressure system that brings a cloud cover to moderate the heat loss at night. High pressure systems have more stable air than lows, so when a high settles in, it is easier to forecast the upcoming days. Sunday's temperatures in both Bethel and Nome were much higher than the climatology predictions. The clear skies from the high that was in the interior were pushed eastward towards Canada as the strong low from the Aleutians moved quickly up through the Bering Sea and brought along with it the cloud coverage here along the west regions of Alaska. And in the winter, the lows and the clouds will produce higher temperatures than the than the highs. In Fairbanks on Sunday, over here, the predicted temperatures were significantly higher than were the actual temperatures. There had been several low-pressure systems in the interior throughout the week, being replaced by a high on Saturday. And temperatures fell Saturday night, manifesting much colder temperatures on Sunday. This is also a year of exceptions for temperatures in Alaska. The effects of El Nino and warmer southerly airflow has moderated the temperatures throughout the entire winter. Had this occluded front been located a couple of 100 miles further east, the cloud coverage would also have affected the interior, and these clouds here that are just along the west regions would have pushed into the interior region as well. We can see that the winds in the isobars are maintaining that that pressure system, and the clouds that would have pushed inward into the interior. And so there would have been cloud coverage present on Saturday that would have continued through Sunday, more than likely, and the temperatures in Fairbanks would have more than likely been much more accurate to the prediction. So we can see with the different methods of forecasting that generally we can get an idea of what kind of weather is coming and what the systems are doing. Obviously, persistence and climatology are not a guarantee, as specific current situations may bring different weather than what is forecast. The computer models are helpful to actually see the movement of systems, and good old human observation can be invaluable. All these methods together at least provide us with generally skilled predictions of what to expect in the weather.